And the photography that we have here is just enhancing it so much. We're so fortunate to be able to have such an exhibit here, to have an opportunity to hear these gentlemen speak about something that I'm sure is very near and dear to their heart. They're very passionate about, very, very knowledgeable. We are able to do this because we were awarded, I'm going to read it because it's long, a Library Services and Technology Act grant. So the library received that a few months ago, and so we are able to have programs of this caliber here at the library. We're very fortunate. So tonight is going to be our cosmic canvas. So I'm very excited to hear what that all entails that involves all of these. The other part of it is, as I don't know how many of you have been involved with doing grants, but one aspect of it is there's always an evaluation. But I don't know how this one could be any shorter or easier. This is it. So at the end of the presentation, if you could just take a second, it may just be some check boxes. But we do, this is part of it, and so please, if you had a chance.
Thank you everyone for coming tonight. My name's Kevin Boucher. I'm going to give the presentation, but we're going to have a number of our Aldrich members who are here tonight and are also took a lot of these pictures, come up and talk a little bit about their journey in the hobby. And I have a lot of their pictures in this presentation too. So save your questions to the end, if you don't mind, because there's a spot for questions and I can answer any questions that you guys want or one of us here can answer. So we'll get started. First of all, this picture that you see in the back here is the California Nebula. It was recently made by Bruce Card right here. So it's a beautiful picture. He tried to get it printed for this exhibit. Unfortunately, the printing company didn't get it in time. He's probably going to be waiting for him when he gets home. So we'll get started. Thanks again for the Lunenburg Public Library. We've been here before. This is our second exhibit here, second lecture, so it's proven very popular, so they keep inviting us, so we couldn't be happier. So first thing I'm going to start with is who is Aldrich Astronomical Society? We're a nonprofit. We're one of the oldest amateur astronomy clubs in the nation. We were started in 1932 in the Worcester area. We do a lot of different things. Library telescope program. There is a telescope that you can take out from this library, but we have them, and I'm going to say that in a second, but we have them in like 177 libraries in Massachusetts. So we place the telescopes, we get them set up, we keep them maintained, and you can take them out for a week or two depending on the policy for a given library. So we do a lot of STEM education with schools, a lot of library programs all around the state, and certainly a lot of outreach at colleges, scouts, that kind of thing. So we're a 501c nonprofit, as I already stated. Our primary goal is to educate people in astronomy. Believe it or not, we have probably close to 190 members in our club now, and everyone comes to me thinking, you must know a lot about astronomy in order to be a member. Well, that's absolutely not the case. I'd say probably easily 3/4 of all the members in our club know nothing about astronomy. They never looked through a telescope before, and the reason why they joined our club is primarily to learn. We have a lot of mentors. We have people that can teach you astrophotography, teach you how to use a telescope, teach you how to build a telescope, so that's a great reason to join. The Adopt the Library Telescope program, as I stated, Lunenburg has one, at least one, but we have them throughout the state, northern Connecticut and southern Vermont. Annually, believe it or not, we have a minimum of 100 events, often more than that, all through the state, attended by over 15,000 people. So we do a lot of outreach work. In fact, we've got multiple events going on today, so we have different members at different places. So in terms of astrophotography, there are actually 3 different types, and they're all represented in this room tonight. Deep space is probably one that you're familiar with when you see a lot of the photography from the Hubble or the James Webb. That's basically galaxies, nebula, star clusters, things like that. We have a lot of those represented in this room tonight. And it requires long exposures. Typically, we will take anywhere from 5 to 15 or 20-minute long exposures. And we take a lot of them in order to get this very, very dim stuff in color in a picture. So there's a lot of stuff you have to learn in order to basically, get the software working right and your hardware working right in order to be able to capture these pictures. Planetary, on the other hand, requires very, very short exposures. So planetary pictures are things like the sun, the moon, any of the planets, okay? Those objects are very bright, so we can take very, very, very quick exposures, and typically we're using a high-speed video camera when we take those pictures. So you don't require a very stable mount. You can actually do it even with a tripod. The idea is that you want to get as many frames as you can as quick as you can, and that's how you get the best photos. But it requires a pretty large telescope, generally speaking. Not so much for the moon, not so much for the sun, of course, but if you're trying to take a picture of any of the planets, if you want to see any details like you see in some of these photos, like in the back here and like the sun here, you're going to really need a fairly large telescope. Nightscapes are really the place you want to start if you ever want to get into learning astrophotography. It's probably the easiest place to start. You can do it with your standard DSLR, so you probably have those at home. And generally nightscapes are where you capture a astronomy type target. It could be a comet, it could be just the Milky Way, or just a field of stars and a terrestrial target. It could be a canyon, a lake, a mountain, whatever, Once again, we have that represented in a number of pictures here. Like that picture over there, where you have the Devil's Tower with the galaxy. That's a composite, but that is a nightscape type photograph that I'm talking about. So how far have we come in astrophotography? These pictures in this room, I'm not trying to, blow our horn here, but pictures like these 50 years ago would have been a dream of a professional astronomer. Okay? To give you a little idea, the photo on the left was taken in 1917. It was taken with the largest telescope in the world at the time. It was taken by professional astronomers, and it was processed, state-of-the-art processing for the time. These are both exactly the same pictures. The picture on the right was taken by one of our members from his backyard, and the member is 15 years old. Okay? So that gives you a little idea how far we have come in less than 100 years in this hobby. And I could show you pictures going back 30 years that would really put, basically be put to shame with a lot of the pictures that are in this room. It's not that we're that great or anything. It's because the technology for the cameras, the hardware, the telescopes that we use, the processing that we use, the processing software that we use, those things are what really have made a big difference and made our lives easier. So I'm going to show you a few pictures. Some of them are not on this wall. We've got a lot of pictures and we only could put so many up. In fact, these two cases are still stuffed with pictures that we couldn't fit up on the wall. This one here is a galaxy. It's a starburst galaxy. You can see it's called a starburst galaxy because it's got a lot of activity. You see all that red stuff there? That's dust and gas that is being expelled from the galaxy as a result of so many stars being formed. This is part of a two-galaxy combo, only one of which is in this picture, that is very, very popular in the night sky. It's a very popular target with us. Marcia Wilcox is one of our members. She wasn't able to be here tonight. This one here is a picture, actually a mosaic. This is over a very, very large part of the sky. This is actually a supernova remnant. So what you're seeing is gas and dust that's being blown out. And this whole structure is getting bigger and bigger every year. The progenitor star, somewhere in the middle there, the star that blew off its outer shell. So this is actually a mosaic. I believe it's a 6-panel mosaic. So Nico was one of our members. He actually took 3 panels on the top and 3 panels on the bottom and stitched them all together into this very large photo. This is one of mine, a relatively recent one that I took. This is called a globular cluster, M13, MSCO 13. A globular cluster is basically a cluster, in this particular case, about 500,000 stars. You will see all the globulars, and there's about 108 or 109 known globulars in our galaxy. They're all towards the center of the galaxy. They were all made when the galaxy was first formed, so the stars in these clusters are generally around 10 billion years old. Our galaxy is about 13 billion years old, so all these stars are generally pretty old. It's amazing. If you lived in a solar system that was in this globular cluster, your nights would never get dark. Because there's so many stars in the sky, it would literally light up the night. It would never ever get dark because you'd have all these stars in your sky. You can imagine it, this is nothing like what, even us looking at the Milky Way. If you're here in the center of that globule, you would never have a night. I also have a galaxy over here. And there's a lot of little ones in here spread out in this photo, but I wanted to frame this particular picture so that you can get that spiral galaxy off on the left. So this is the Elephant Trunk Nebula. It was made by one of our members, Donna, right here. And the reason why it's called the Elephant Trunk Nebula is this structure right here. It's got that elephant trunk type shape to it. This is a big gas cloud in space, and it's also a big star forming region, so there's a lot of stars forming. In fact, if you look really careful, right in this area here, there's some very large stars being formed right where that dust and gas is thickest. Now this is an amazing picture in my mind. I mean, Donna tells me she's only been at this hobby for a year. So this is what's possible after a year in the hobby. I think that's telling. This is another one of mine, Cocoon Nebula. It's another star-forming region. And whenever you see a reddish, pinkish hue like that, that particular color tells you that you're looking at a lot of hydrogen that's getting lit up by the stars that are being born in that cluster right there. You can see a lot of dust. It looks kind of smoky all over the place there. That's just a lot of dust that's in the area that the stars are not currently lighting up. And this is right in the Milky Way, so it's in the thickest part of the stars that are in our sky. That's why there are so many stars in the background in this picture. Crescent Nebula. This one was done by Tom Lucia, who's in the back here, another one of our members. You can see why it's called the Crescent Nebula. It's got that crescent look to it. It looks like a big brain in space. In essence, this is another supernova remnant per se. I mean, that progenitor star right there blew off its outer shell of gas, and that's what you're looking at. It's actually what's called a Wolf-Rayet star. Really big, very strong winds coming off that star. This one here is one of my later ones. In fact, I've got that in the back on the wall there. I just had it printed up. This is the full frame version of it. And this is called the Needle Galaxy because we're looking at a spiral galaxy, but we're looking at it edge on. What I liked about this picture, and if you look really, really close, you can see some neat spirals in the background here. This is another edge on here. There's another irregular galaxy here. So there's a lot of other galaxies further in the background in this picture. Triangulum Galaxy by Steve Bodine. Now, what I liked about this photo, this was taken with a standard DSLR. How you doing, Bruce? Another Aldrich member. Steve Bodine took this picture with his DSLR. So you can take really beautiful deep sky photos with DSLR cameras. M45, Pleiades Nebula by Linda Pinto. Linda didn't make it here tonight, but a lot of his pictures are here. And this is a beautiful picture. What's cool about this, quite often the stars, when you see in a nebula like that, the stars would typically be born in that nebula, but not in this case. In this case here, all these bright stars are actually traveling through space, and they actually just so happen to run into a big dust cloud and lit up this dust. So It's kind of more of a happenstance picture, but it's still very cool. You can see this in the night sky if you looked up. You wouldn't see all the gas around it, but you would see the bright stars. But you could see it easily with the naked eye. This picture was taken by Bruce recently, and I don't know if you remember that they were talking about a potential aurora making it all the way down to our area, which is rare. Normally, they don't make it this far south. And that aurora was being caused by this big sunspot right here. So this was taken with a white light filter in his backyard. You want to speak to it at all? Or?
So the large sunspot to the left there, I forget the numerical number for it, but it was actually visible to the eye just by looking through the filter. It's actually one of the largest sunspots on record, and you can see it visually. But I shot this with a DSLR with a simple refractor and a white light filter. I shot it in a couple different series to sharpen up the focus and then process it.
So I'll put a caution here. Whenever you're doing solar work of any kind, whether it's visual or with a camera, if you don't use a special filter, now we call a white light filter, it's for all intents and purposes like welder's glass type of film that we put in the front of the lens of the telescope. If you didn't do that, you'd either be burning your sensor on your camera or you're literally burning your eyeball out because that's how strong and bright it is. So you do not actually ever look at the sun with a telescope unless you have a filter on it, or have a solar scope. There are specialty telescopes, our club has them, that you can actually look at the sun. We have some pictures made with solar scopes. Oh, right here. This is a great picture right here, made with a solar scope, and it basically really shows you the chromosphere of the sun, which shows you a lot of details. So you definitely want to check that picture out. That was taken by Len DePinto. So the lunar V and lunar X, this is basically the sun, basically at its terminator. So this is the terminator. You know, the sun's off this way, and the light is shining across some craters, and they happen to basically create a V shape and an X shape, and you can only get them 1 or 2 nights a month, and only for an hour or so on that given night. So you gotta look up the exact timing in order to be able to capture that. I don't have that picture up on the wall, and I know it's hard to see, but I tried to bring these photos out so you could actually see the features a little better. But that's kind of a cool shot. Somebody in our club challenged our astrophotography group to capture this, and all of us went out and tried to capture it one night, and we all did a good job with it. So this is a picture of Mars. Now planets are tough. Like I said, Len took this picture back in 2020. Mars wasn't like as close to Earth as it can get, but he still managed to capture a lot of the surface features of the planet, this is actually the North Pole down here at the bottom. Just the way the optics are, it gets reversed, but yeah, he managed to capture some decent surface details just the same. So I wanted to show you some planetary stuff. Here's another example of a good nightscape photo. I don't know if any of you are familiar with the Stone Bridge near the Wachusett Reservoir, but this is where he captured Comet Neowise, which was in, what, 2020, I think, right? Yeah. Comet Neowise. We all captured this. We had a whole stack of pictures of Comet Neowise from all of our members that were in the astrophotography group, so it was well represented that year. This is a recent one from Donna. She captured a great one here. They kind of nicknamed this one the Green Comet for obvious reasons, but she really captured not only the comet halo, but both the comet tail and a bit of the ion tail here, I think. So she got some nice details in this photo. Did you capture that with a DSLR, Don, or was your astronomy camera?
Astronomy.
Great. Yeah, nice job with that. So this is a classic example of a nightscape composite. Okay, so what is a composite? A composite is basically where you're taking multiple different pictures and you're using like Photoshop or GIMP or something like that to actually compose them into a single photo. So actually this whole top half here is a picture of the Milky Way. We actually have it, I think, in the box here. And he actually took a separate picture of the White City Bridge there in Worcester and Shrewsbury over Lake Quincy at night, and he basically put them together to create this kind of cool composite. This one is one that I actually have right there. Now this picture I took of Devil's Tower when I went out to the solar eclipse, which is the one in the back there. We went out to Idaho, we went to capture the totality for the solar eclipse on the on the western slopes of the Grand Tetons. And on the way, me and my wife stopped at Devil's Tower, and at twilight, I captured this picture at the bottom half. So basically this whole bottom section was captured at night, or early evening. This photo I took of the Andromeda Galaxy I took years ago, but I just thought, I wanted to kind of get that, Close Encounters of the Fourth Kind type feel. So I said, wouldn't it be cool to throw a galaxy in there? And honestly, this particular galaxy, even though it's one of the largest in our sky, is nowhere near that size. And even the stars, I didn't like the stars in either the galaxy picture or in the picture of the Devil's Tower, so I actually went out in my backyard and took a picture of the stars only just so I could Photoshop them in order to get a composite that I actually liked. So this is not a real photo. I mean, bits and pieces are. They're all separate pieces of real photos, but they were assembled into a composite. And finally, this is in the back of the room here. This picture was taken, other than the eclipse itself, the whole background was taken by my wife, Nancy. She was taking that picture while I was kind of worrying about grabbing this picture here. But this picture that you see was taken during totality, so what's cool about totality, it's the most coolest thing you've ever seen. You look up, you can see the stars, but 360 degrees around you, it looks like sunset like this. Because you have the shadow of the moon right over you, okay? And the eclipse, the sun, is being shadowed by the moon right here. And you can see these little red dots. Those are actually solar flares coming off the sun. And so is in this corona here. And you can actually look at this with your own eye. So you don't need any special glasses or whatever. You can just look at it. And that's the only time you can really look at the sun without any help, without any aid whatsoever. So this was all done in 2017. And once again, this is a composite. I composited all the photos I took of the sun transiting before and after, and then just put the full eclipse picture in the middle there. So it didn't even transit in that direction. This is an assemblage of, as you can see, 9 photos, well 10 photos total, just for the look of it, basically. So let's speak a little bit about the challenges of our hobby. And trust me, I wanted to do exactly that. And everybody in this room is lying to you if they haven't told you that. Anybody that is in our group has done astrophotography. It's either your camera's not working, your focuser is not working, something, the software, the process is not working, something's not working. So we have a lot of challenges in this hobby. One of the challenges is that we want to take long exposures. I kind of touched on that. Any of these deep sky photos of galaxies or nebula, you got to take a lot of long exposures. Unfortunately, the Earth's turning. And since the Earth's turning, what you get is this, okay? So we're taking pictures of the worst thing you can possibly take pictures of, and that is stars. Those are just point sources up there. This is what you would get if you didn't have a telescope tracking mount that's probably got auto guide, and I'll explain to you what that is going on. This looks like it's really bad, but this is probably only like 20 to 30 seconds of exposure. 5 minutes is what we've got to try to do in order to get the really dim stuff that we're taking pictures of. So what you're shooting for is nice round stars like this. And what we've got to deal with is this if you don't do it the right way. Okay? So how do we solve that problem? We do it by using software and hardware. And I'll explain what we got. This here is actually my setup in my backyard. I have a 8 by 10 foot observatory, so it's basically a shed, but the roof can roll right off the shed. So, and in there I've got this telescope. This is the one I primarily do most of my imaging with, my camera here, and this is my computerized mount down here. So the way you basically stop the stars from streaking in your photos is you typically have 2 cameras. So I created this photo here. I got this photo off the internet because it was well labeled. But typically you have an imaging, a guide camera and a main imaging camera. So this camera is the one taking your pictures. This camera here is basically connected to software like this. This is actually free software. And what this software does, all it does is allows you to put a crosshair on a star in the sky, and it tells the mount, this guy right here, because the computer is connected to the mount, it tells this guy if that star moves so much as a millimeter or a micron in any direction, move the mount in the opposite direction. So the idea is that you want to keep that star in the crosshairs perfectly all night long so you can continue to take pictures. So that's what's called auto guiding, and that's how we solve the problem of taking long exposures of things like stars. And of course, if your stars are streaky, then your nebula is going to be a mess because it's not going to be very sharp. So the idea is to make it.
One thing to mention about the auto guiding is that's a relatively new phenomenon, and when you first, like back in 1999 when I first started, I had to sit with a paddle and a crosshair the eyepiece and look through the eyepiece and do it manually. So the fact that we now have, this is a good example of how technology has made it a lot easier. Auto guiding makes it so we can do other things while taking pictures too.
Absolutely. In fact, typically I set my setup to, I just open my roof, I get my sequence started. It knows when it gets dark. It will automatically start running. It'll do absolutely everything automatically without any intervention whatsoever. I periodically will check on it from my house, but I don't even go out to the observatory ever. And it runs all night long while I'm sleeping. And when the sequence is done, it'll actually tell my telescope to park itself. So it'll put it in a position where I can close my roof. And all I do is I go out in the morning and I close my roof. Shut my laptop down and bring it into the house. So it's completely automated, and believe it or not, that sounds like a very expensive thing. Almost all the software that I use to do that is completely free. So,
No, it's so much bought us. He does it worse. When I do it, things catch fire. Skunks have moved in. What else?
well, you don't have the observatory though.
Yeah, I know. I just leave it. Oh yeah.
That's a big.
Things outside. In my case, I've set up every night. But there are skunks that come up while I'm setting the thing up and bump my foot. I'll say, "Hey, your foot is a juicy grub there."
I almost stepped on a porcupine coming out of my observatory. So the other really critical thing is focus, and you can see on the right here, this is an example of not perfect focus, and then this is still not perfect. The stars are getting a little better, but it's still kind of blurry. You really want all that subtle detail. And then finally you get to this in focus. And so critical focus is important, and there's a number of ways to do it. You can do it manually. We use this mask here, it's called a focus mask, and it actually goes on the front of your telescope objective. And what it does is it allows you to look at a bright star, and you're going to see this kind of thing, this kind of pattern on the star. And you see how that center line there is moving left and right? Well, when that center line is dead center between the other cross, you know you're in perfect focus. But here's the problem. Focus, especially New England, focus will not last more than about an hour because the temperature is changing at night. So if it's winter, it may only be 30 minutes. because as the temperature is changing, believe it or not, it's contracting or expanding your telescope itself. And that is adjusting the focus enough to make things blurry. So if you're using the manual approach, you can't do what I do, where you basically go to bed and let it run all night long. You got to literally go out there every 30 minutes to an hour and basically readjust the focus using this technique again. What I use is an automated focusing. So there's basically a little electric motor, stepper motor, that's attached to my focus wheel. And there's software that will automatically get focus. You know, you can have it do the focus either every 30 minutes, every hour. You can say, I only want to refocus if the stars are out of focus X%. And the software will do all of that automatically for you. It'll refocus and then it'll just start the sequence on again. So it's some great software. And once again, the software that does all of this is free. You have to pay for the motor, but the software that does all this is free, so which is really nice. So the other challenge is the targets that we're taking pictures of, and I kind of touched on this, is the targets are really, really dim. And so here's an example of what a single 5-minute exposure looks like. I mean, it doesn't look horrible, but you know, there's a lot of noise in here, and you know, the nebula is not super crystal clear. But when you take 60 5-minute exposures and what we call stack them, you get something a lot better. Let me go back. Oops, let me go back here. So this photo here is 60 5-minute exposures. It's actually a picture that I took a bunch of years ago. The noise that you can see on the outside is pretty much gone. You see far more detail in the nebula itself as a result. And what stacking really is, all it is you're taking the 60 photos and the software actually averages the values of all the pixels in the photo from one photo to the other. And if you average, the things that are noisy are random. So noise is random. Noise, on every picture the noise moves around a little bit. So if you average, if you imagine every single little dot in this photo is a pixel, every pixel has got a number associated with it, and every one of those numbers is average. That's all it is. It averages all the 60 frames, and the result of that is it actually just leaves you with your picture, and it takes all the noise out. So it's a very, very good way of doing it. You can use, once again, free software to do this. There's free software out there that will do all this for you. So this is an example, once again, same thing. This is one picture, 8 averaged together, 66 averaged together. You can see how the trend is. It gets better and better. So, as you can imagine, there's a lot of technology in this hobby. You know, I've talked about telescopes, mounts, focusers. I talked about obviously the different cameras that we use, all the different software that we use to process the pictures afterwards. So it sounds like it's like an overwhelming thing to learn. It absolutely is not, especially nowadays, and I'll tell you why. First of all, let's show you what the cameras look like. This is an example of an astronomy deep sky camera. This is a camera made specifically for astronomy. This actually looks exactly like the camera a lot of us in this room actually own, because it's like the new hot camera to buy. And actually the sensor, to take the pictures in these cameras is exactly the same sensor that are used in a lot of the popular DSLRs out there. But you can use DSLR cameras to take these pictures. This is an example of the type of camera you'd want to use. It's a video camera. It's a type of camera you'd want to use to take pictures of the sun, the moon, any of the planets. Because they are made to create, one, they're sensitive to low light, but two, my particular camera, I can get it up to like 200 and something frames a second. So I'm trying to get like anywhere from 5,000 to 10,000 frames in 3 minutes before the planet starts to rotate. And of those frames, the software looks for the best frames in the picture. And the reason why some frames are good or some are bad is because we're basically taking pictures through atmosphere that's literally swimming. The air is blowing in different directions up there, but every now and then, for just maybe a few milliseconds, you're going to get some still air all the way up. That's when your frame is going to be sharp. So what the software does is it looks through all 10,000 of your frames and it says, you know, these are the best. It's going to rank them all. And it's going to say, you can say, I want to use the best 10% or the best 20%, and then you stack them, just like we do with all these photos, to actually create a final photo. So, in terms of the software that we use, we have software to capture the pictures, control the focuser, you know, do all that kind of stuff. So it actually takes the pictures. This software I kind of spoke about already. This is the auto guiding software that keeps the mount and all the stars perfectly round all night long. If we're using, if we're taking planetary stuff, we use different software that works with the video camera. So this is another free software that you can buy. Not buy, you can just download, that actually runs the video camera to do the planetary stuff. Of course, we have to do the manual and autofocus software, and then we have the software that aligns the stars in all the images and stacks them or averages them. And then finally, to pretty it up, we use software like Photoshop, and most of us use a very popular software made for astronomy pictures called PixInsight to really, you know, get the final results. But the beauty is, you can learn all of this. It takes time, yes, but unlike when I started, there are 1 million YouTube videos on every single thing that I've talked about that go into very, very good detail and to try to make it very simple for you to be able to do this stuff yourself. Every single piece of software, I mean, you can find 2,000 videos on processing the Orion Nebula or whatever. I mean, it's crazy the amount of content for free that you can get on YouTube now. So, for learning some of the latest software that we use now, a lot of us are just using YouTube videos. It's great, great resource. The thing I can't stress hard enough, though, is find a mentor. Find someone like anybody from Aldridge in this room that's been doing it for a little while. It will cut your learning curve down immensely. I'm impressed with Donna. You didn't have a mentor, right? You learned this on your own. So I would highly recommend you can cut, you know, for me, I wouldn't show a picture to anybody for the first 5 years. I mean, I was learning from books. You know, I started almost 25 years ago with astrophotography. And I did it primarily because I was into visual. I was looking at this cool stuff in my telescope, and I wanted to take a picture of that so I could show it to my friends, and that's kind of how it all started. But the learning curve for me, there was no good cameras, there was no YouTube, never mind YouTube videos. YouTube didn't even exist, and so I had to read books, and there weren't a ton of books on the subject at the time either. So I mean, Joe started. I know Len started a long time ago too. I mean, you started a good long time ago. So it wasn't as easy as it is now. Highly recommend. Join a club. Find somebody that you know that is doing this and can kind of get you to getting pretty pictures like this probably in months versus years. So here's a little example of what our backyard observatories look like. For the people here tonight, this is Bruce Card. Bruce's observatory, he just finished building that last year, right? Yeah. So basically that's a roll-off roof observatory. So the roof rolls off there right onto these rails. And his telescope's inside. Len DePinto, who's got a lot of pictures here tonight, he's got a roll-off roof observatory in his backyard, and this is his setup. This is mine. So I have a roll-off roof. It's an 8 by 10 foot shed with a roll-off roof in my backyard. I built that myself. Although these aluminum rails I had done later because I won't get into the story, but I had a lot of problems with my wooden rails after the first 10 years. Things started to check and twist. And of course, one of our astrophotographers that is represented tonight has a dome-type, plastic dome-type setup in his backyard. And last but not least, we have a number of members that literally set up all the time in their, on their driveways or at our observatory site in the Rutland Ocam area. Aldridge has an observatory that it's for memory use only, basically. It's like 7 beautifully manicured acres. We got a big observatory with a roll-off roof and 40-something scopes in a storage building that members can use, and a lot of these concrete pads around the field that you can set up your gear on. So, but that's, you know, all these pictures were, my point is all these pictures here in this room were taken from our backyards, you know, so, or at the observatory site. So I want to talk, and a number of us are going to step up and talk about this for a few minutes. I got into astrophotography, well, I got into astronomy actually, me and my wife on our 10th anniversary. We went to Arizona and to Sedona. And beautiful place, very dark skies. We actually went out into the desert a few times with the 4x4 that we had and just lied on the windshield to look up. It was just stunning skies there. But on the roof of the restaurant that was part of the resort, we had an amateur astronomer like I am now that had his Dobsonian telescope up there, and he would show us targets in the night sky, and from that point on I couldn't wait to go out there every night with this guy. He was out there every night that we were staying there. We stayed there a week, and that got me hooked. You know, I was hooked from that point on, and when I got home, it was within a year or two that I had my own telescope, and a friend of mine actually won the very earliest version of an astronomy camera that ever came out. Very, very primitive, but he won it at one of the very first astronomy shows that, it's a Rivers camera, it's in southern New Hampshire where the college is. I forget the name of the town, but in any case, they had this show, and he won the raffle, and he gave the camera to me. So that was my first foray into photography. Some of these guys have, I think you, Joe, you started with film, right? Yeah. So some of these guys started with film. I know Len started with film also. And that got me hooked, and I've been in astrophotography ever since, and absolutely love it. So I've been doing it, and whenever there's a clear night, whether I'm home or not, if I'm not home, I'll get the rig started. I'll get my roof off, start the laptop, and let it do its thing, and I'll do whatever I want to do, even if I'm gone for the night. And it will do its thing even though I'm not home, and I'm going to capture images because we don't get a lot of really clear, nice skies here, so we got to capture them when you can, right? So that's basically, that's my story. I'm going to step up. It's up to you, boss.
Wow. Pressure.
Yeah.
So my journey began when I was just a kid. And so one of the things that we like to do in the club is we always encourage families to join, especially kids who have an interest in space and astronomy and physics. And we've had a number of children that we have mentored through the years that have been an absolute joy to work with. You know, they learn the sciences, they learned different parts of STEM, and they are in turn sharing this with their friends. As a kid growing up, learning astronomy on my own, not having YouTube and, you know, access to the books that they have today, and just being under the night sky, using a simple telescope, discovering the planets, and then becoming an adult, finding the Aldrich Club, and going on from there. It's been a journey that I've enjoyed. But it all started when I was a kid, and that's why we've always encouraged families, if your child shows an interest in the sciences, in STEM, math, all those different parts, you know, encourage it. You know, find groups that, you know, will help you with those things, like astronomy clubs or any other type of, you know, club that, you know, works with kids like that. So, but photography, I started in about 2012, deep sky stuff. Before that, I was using film, you know, the stuff we don't have anymore. Yeah, what's that? Film. You know, using my 35 millimeter and trying to track the object manually across the night sky. And having recently found some of my old works, it's sad the stuff I was doing. All out of focus, you know, and I'm saying to myself, now I know this is Venus, but it certainly didn't look like Venus. And then to what we're doing today, this is, you know, leaps and bounds from, you know, what was to what is.
And, you know, a lot of it comes from the scientific community. They're very open and they're very sharing. That's where all this open source material comes from. And, you know, we're creating our own Hubble-style images in our backyard. I live in Worcester with this big sky globe, and, you know, this is the kind of work that I'm doing in my backyard. It's not necessarily a dark sky site. So anyways, if anybody else would like to, you know, say a word, feel free.
Sure. I started, like Kevin, I moved to Winchendon, which isn't too far from here, back in the 90s, and I lived in the middle of this dark site. And I'd go out every night and I'd go, gee, nice to have a telescope. So I got my first reflector telescope. And then I joined an astronomy club where people had bigger telescopes, and so then and the advantage of having a bigger telescope is you get to see more things, right? So I would look at it with my telescope, and it would look like a little puffball, and then I'd look at it through my friend's 8-inch Schmidt-Cassegrain, and you could see like that picture of the globular cluster that Kevin showed earlier, and you can see all the stars, and that's it. And then like Kevin as well, I wanted to be able to share it with my friends, so I wanted to learn more about taking pictures, and that's kind of how I got into it. And also, when I first got into it, I was able to join a local astronomy club that was based out of Fitchburg. If you remember, Fitchburg used to have a planetarium and all, so we used to meet in the planetarium. And so that kind of got my interest even more. And then I kind of got out of astronomy for a few years. I never sold my stuff, so I always had it. And then I was at work and I won an anniversary for 5 years on the job. And one of the things was a little travel telescope. And then I got that and I was like, why did I ever stop this? And so I got back into it and started doing imaging and taking pictures. And my wife was tired of hearing me talk about all the details of taking the pictures. So she said, you should join an astronomy club and talk to people who will understand you and want to hear what you have to say. So I did that, and it's been a great, having Kevin and Bruce and then everyone, it's really good to be able to share. We went to the NEAF Astronomy Convention in April and learned a bunch of new techniques, so it's a great hobby, and I love it because I'm always learning new stuff and learning from people who are also passionate about it. So
Great, thanks, Joe. Donna, you want to say something?
So, I'm new to the club as well as anything to do with telescopes. So about a year ago, I used to watch this show called How the Universe Works, if anyone has ever seen it on the science station. It's amazing if you've never seen it. So I used to watch the show all the time, and I was like, oh my God, I can't believe what's going on in the universe. So one day my husband says to me, do you want to get a telescope? I'm like, yeah. So we got a telescope. We were doing visual with this telescope. It was an 8-inch Schmidt-Cassegrain. And so we were doing visual. I saw Saturn, and when you see Saturn, that hooks you right in. So,
is that me?
Yeah, right? So we did that for a while, and I said, I like to take pictures. When you see these pictures of Andromeda, I'm like, how do people do that? So I am a product of the new technology, YouTube, the latest technology in the hardware and the software. So, I worked really hard. I just watched a million YouTube videos, talked to anybody who listens to me. My 2 sisters adhere to me. They've heard all about it. And just worked really hard and somehow figured out how to get something. And the first time I took my first picture of Andromeda, I was dying because it was actually something on the screen. And from that point on, it just sucks you in. It's like you can't get enough. Now I have 3 telescopes. And it's only been literally a year since I started doing this stuff.
There is a lot of dents in our walls for my head though. Dents, I'll say.
So he helps. He's my crew chief.
I like to build schools.
Yeah. He helps me set it. It's heavy. You gotta like this thing. We don't have a nice little shed like you guys.
It's coming.
pole alignment, and I'll sub when I first started, So you learn all of these things. It's very complicated, no doubt, but extremely rewarding, and I love it. So.
Awesome. Yeah, the pictures that Don has done after a year, it's amazing to me, honestly. Do you want to say anything, Bruce, or?
I have a slightly different point of view for you. I'm interested in the technology. So, in the 80s, I did film work too. And about that mention of things being on fire, we used to soak film chips in hydrogen under pressure and gas. And when hydrogen catches fire, you can't see the flame, but you can sure feel it. So that was one of the things. Nowadays, I'm doing much more safe things. And I'm trying to combine telescopes with another hobby, ham radio. And so I'm attaching two rather high frequency, relatively small antennas to the telescope so that it can then track satellites. And you can send a signal to the satellite, and the satellite will relay it back out. Currently, the space station ISS has an automated relay. There's several other satellites up there that can do that too. I've asked the Chinese embassy in Washington, D.C. if it would be okay to communicate with the Tianjin, and they have very carefully not answered this. And I'm also very interested in the planetary photography, which is called lucky imaging, which we mentioned earlier. That will turn most computers into slang because of the speed of the data. If it's a rewarding sort of thing that's very, very difficult to do, I know.
It's the challenge.
Yeah, sure is.
So this is the end of the presentation. If you guys have any questions, we'd be glad to field them from you.
And if at all.
By the way, you don't have to join the club. I know this is sort of a funny thing. I'm obviously a member of the club. But come and visit and then decide if you'd like to do it.
That's right. Yeah.
We've had many people come just because we are open to the public.
Yeah.
A couple times, they get questions answered, they brought telescopes in to, can you show me how to use this? And we do. I've had trouble putting it together, I don't know exactly what to do. We build the telescope out right there for them, and they'll go, oh, now I get it.
Yeah.
And off they go, and we never see them again. So again, it's,
Yeah.
it's what it is.
Yeah, the only thing you can't come to, you can come to any meeting, the only thing you can't come to is the observatory site. That's a members only thing. So we have to have some privileges for our members, right? But you had a question?
Yeah, I did, and I may have missed the explanation of it, but just to get right down to the basics, a lot of the pictures that you showed us, the slides, you talked about dust. What is that composed of?
It's composed of...
Dust.
It literally is dust. Yeah, it's basically just various, silicates. It's really what planets are made of, but it's just in its basically sandy form, even finer, almost like smoke almost. I mean, it's really, really fine, So when we look at a lot of these nebula, you're looking at what could be 20,000 solar systems would fit into that area. And it really, a solar system forms because literally, these little particles start kind of attaching to each other, initially electrostatically, but eventually enough gravity forms, and then that kind of cascades into a star is born. And then a star will actually form its own gravity well, which then forms the planets, and so it's kind of like an ongoing thing. When that star blows up, it blows up all the planets a lot of the times, and you start all over again. It's just an ongoing process. That's what's, honestly, that's one of the coolest things about astrophotography. You get to learn about what you're taking pictures of. The energies, the size of what you're looking at, all the science behind what it is you're taking a picture of is very cool. The distances involved, all that kind of stuff.
And there's opportunities to do citizen science too.
That's right.
I know you do some citizen science projects.
Exoplanet transit surveys, for NASA.
And I don't know if you remember a few weeks ago, in May, in May, they discovered a supernova in a galaxy that's 26 million light years away, and it was that they want amateurs to help them. They want amateurs to help them find these things so that when someone finds it, they can point all the big telescopes at it and collect all the data. So there's opportunities for citizens to do real science, which is kind of fun.
Many amateurs are making discoveries, like the last supernova that happened in M101. That was discovered by an amateur. Many comets are being discovered by amateurs, as are asteroids. All types of deep sky phenomena being discovered by amateurs because we are constantly looking throughout the whole sky, photographing different parts of the sky.
So there's a lot more of us, right? I mean, there's only so many of those there, but there are millions of us, telescopes and cameras in our backyard, so we can actually film a big niche, so the scientists love talking to us whenever we go to any shows, right? Mm-hmm. One of the things they have is a big program collaboration sessions where the scientists parade through, and they're begging you to join their survey or whatever it might be. They're really into it. So you don't have to take pretty pictures. You can do photometry stuff, which is basically just measuring light. That's one of the things I got involved with the James, not the James Webb, the telescope there. That basically is just looking for planets around other stars.
Tests.
Yeah, tests. Thank you, tests. So I'm in the test TFOP. They call it the TFOP program, test follow-up program.
So the professionals rely a lot on the amateurs to fill in very large gaps.
How do you share that information?
There are channels that we can send our information through so it gets forwarded into the scientific.
So potentially a photograph?
You upload your photos, and they in turn put it into their database for further analysis.
So the closest one to us is Harvard Smithsonian. So if we made any type of a discovery, we would reach out to them, and they in turn would research it and catalog it. And if they find that Joe made the initial discovery, then his name gets attached to the little file.
That's cool.
So earlier I was speaking to kids being involved in astronomy. So this goes to amateurs being involved. So a young lady whose father actually helps manage and establish the Northeast Astronomical Imaging Conference at where we go to every year in New York. Okay, she was 13 years old, amateur, and she was photographing M82. And she discovered a supernova.
Was her dad still, I think?
Yeah, she was running the camera, doing images for a project, school project she was working on. She photographed the supernova for the first time, and her name was, on the lips of every amateur professional astronomer the first, 6 months, because she made the discovery, and now everybody turned their telescopes to M82, including me, to photograph. So I mean, it's there. For anybody, any amateur.
Oh, I was going to ask you about the M101 supernova, and I got pretty lucky on that.
Oh.
I heard about it, days after we discovered it.
Yeah. But
then went back and I had image M101 like a week before, and then luckily I had caught some on the rise, so it was faint, but you could tell it was there, and then I just imaged it every night until the sky.
Joe did a bunch of them too. A lot of our members got pictures both before and after. It's a popular target, so a lot of us amateurs are taking pictures of it.
It's a bigger galaxy too, so it looks good when you take a picture of it.
Right, exactly.
It's easier to image. Supernova. I've never seen a supernova.
So what is your setup that you have?
I have a 8-inch mid gas.
Great.
I know it's not the greatest thing for photography.
Yeah.
But I got a good mount for it.
Oh, good.
826 hard pro.
Oh, good.
Yeah.
Good.
But that was really interesting. But I wonder if anyone else has had a similar start. I've been doing astrophotography for 5 years. I had an old Newtonian reflector, and I started out using my smartphone with one of those clamp thing
Yeah,
to hold on, and I took a picture of Jupiter, I think, and I got home.
Yeah.
And the moon was easy too.
Yeah.
You know,
I've seen some amazing photos from smartphones.
Oh, yeah. I
But
went
yeah.
through 3 of those different clamp things.
Yeah,
And then I said, I'm just gonna get the real thing.
So for any of you, if you want, talk to us, and we'll be glad to show you maybe pictures of the spirit stills we have.
Yeah. That's great. So you're a classic candidate for us then. Any other questions? All right. Well, thank you very much for coming on tonight. I appreciate you spending some time here. The gallery exhibit's going to be here for the whole month of August. You probably know that, but
Feel free to come in and check them out anytime. We'll be here for a little while if there are any questions about any of the photos. And we'll take it from there.
yeah. Thank you very much.
Thank you.